Hello friends, it's Lagrangian here, and today I'm going to solve this problem of classical mechanics. And the question is, in inverted pendulum consists of a particle of mass m supported by a rigid massless rod, okay, of length L. The pivot O has a vertical motion given by this equation. Obtain the Lagrangian and differential equation of motion. Now here you see, according to this question, a particle is supported by a rod, this rod, okay, and this is the point. Pivot point means this is the mass m, and this rod is fixed at this point. This is O, suppose, and this point also has a vertical motion up and down like this, right? Which is represented by this equation. Okay, so now let me show you how to answer this question. Now let me clean this board. Okay, first note the question, pause the video. Now you see, this is the rod and this is the particle of mass m. This is the point pivot, which is O, and it has motion given by this equation, vertical motion given by this equation. Z is equal to A sine omega t. This rod is massless rod. This rod is massless rod. Okay. This rod is massless rod. Okay. The equation, this is the equation of motion of the pivot O is this is the equation, right? Now here you see, it must have two accelerations, and here two different motions are involved here. You see, one is this point O has vertical motion. Another is, this is a pendulum, inverted pendulum, right? And so it oscillates like this. Okay, it will oscillate like this, right? Now you see here, length of this rod is m, and here we have acceleration due to gravity g, which is downward, and one more acceleration will be there, that is due to the motion of this particle, this point, vertical motion of this point, that is that will be given by as its motion is sinusoidal. Here you can see it's sinusoidal. Sinusoidal means, so the sine graph like this. This is positive, this is negative, again positive, again negative. That means it is going up, down, like that, right? So now you see, so here you can see, so if you want to find the acceleration due to the motion of this O, that's gonna be equal to, if you differentiate it with respect to t, then you're gonna have a omega, which is function of function. Here you see, this is function of function. If you differentiate this, then you should get omega, then sine omega t, that's gonna be cos omega t. Now this is velocity. Now again, if you differentiate it, then again you're gonna have minus a omega square, and derivative of cos is sine omega t. That's what you're gonna get, sine omega t, right? Now you see, if this angle is theta, this angle is suppose theta, let me consider this angle is theta. Okay, now this length, this arc, this length of the arc will be given by L theta, right? Length of the arc will be given by L theta. Okay, Now what will be the velocity of this particle, oscillating particle? That will be given by, time derivative of this, right? If you find the instantaneous velocity of this particle, then you have to differentiate with respect to time. Now here you see kinetic energy, that is T, which is equal to half m v square. Here instead of v square we have to take L theta dot, that's going to be velocity. Here we're going to get the angular velocity. This is oscillating like this, right? So here we're going to get angular velocity, so square, right? So hope you have understood this. Here the velocity, this velocity will be equal to this. So L is fixed here, L will come out, then d theta by dt is represented by theta dot, right? So theta dot is the angular velocity, right? Now how to calculate the potential energy? How to calculate the potential energy? In order to find the Lagrangian, we need to find the potential energy. Kinetic minus potential energy gives the Lagrangian L, right? So here you see how to find the potential energy in this case. Now here you see this is the level of zero potential, suppose. Let me consider that. And so height of this particle from this level will be given by this part, right? This portion, this height. And from this triangle, as you can see here clearly, from this triangle, what you can do, this is the triangle, right? This is theta and this is L. Then this side will be, now let me make it, suppose this is O, this is A, this is B, suppose. Then here cos theta will be equal to, base by hypotenuse, that is OB. Here cos theta is equal to OB by OA, right? OB by OA. So therefore OB is equal to OA into cos theta. OB is equal to OA into cos theta. OA is nothing but L. So we're going to get this OB is equal to L cos theta, right? So that's why this part becomes L cos theta. And we know that potential energy is mgh. Here this h is equal to this one, L cos theta. So but what will be g? Here I have already mentioned that two different acceleration will be involved here. One is g, that is acceleration due to gravity. Another is z double dot. And z double dot, here you see the resultant acceleration g dash, that's going to be equal to g minus z double dot. Now here you see, let me tell you something. Though you are getting here z double dot minus this, don't when you put this value here, don't make it positive, right? Don't make it positive. Okay, a sine omega square sine omega t, a omega square sine omega t, don't make it positive, because now you see this angle varies with time in such a manner that this sign will be always minus, right? Hope you are getting my point. Okay, so if this is the resultant acceleration, then mass is m, resultant acceleration is z minus a sine a square, a omega square sine omega t, right? So now you see that means this is sinusoidal, right? So you know the sine graph, half cycle positive, half cycle negative, right? Okay, so when it moves ups and down, this angle change with this angle will change with time. Okay, so that this sign will be always negative, right? So in that case, here mg, this part is the acceleration, into h. So here height is L cos theta. So here we're gonna put L cos theta, right? So draw the diagram properly. Okay, so let me draw the diagram again clearly. Now here you see we have got the kinetic energy, we have got the potential, and so the Lagrangian L is given by T minus B. Okay, T minus B. Then it's gonna be equal to T is this half M L theta dot whole square, or you can write it this way: L square theta dot square, L square theta dot square. Then minus M into Z A omega square sine omega t, sine omega t, sine omega t, right? Then L cos theta, L cos theta, L cos theta. Okay, so hope you have understood this. This is the Lagrangian. Now let's find the differential equation of motion, right? Here you see what we are going to do. Let me clean this part. Okay, so this is the Lagrangian we have got, right? And from here we're gonna use the Euler-Lagrange equation. So that is what? That is time derivative of del L by del theta dot minus del L by del theta is equal to 0. So we are going to use this equation. Okay, so now let me clean this part. So let me keep the Lagrangian only. Okay, so pause the video and note it down. We have got the Lagrangian. So now let us use the Euler-Lagrange equation. That equation, that is time derivative of del L by del theta dot minus del L by del theta is equal to 0. This is suppose equation number 1. Now let us find del L by del theta dot. So if you differentiate it with respect to theta dot, then what you gonna get? This part is only the function of theta dot, and this part is not function of theta dot. That's why that part gonna be equal to 0, and this part will be equal to half into ml square 2 into theta dot. If you differentiate this with respect to theta dot, then you're gonna get 2 cancel. So what you're gonna have here, you're gonna have ml square theta dot. That's what you're gonna have. Now if you find a time derivative of this, in order to get this part, if you differentiate it with respect to time again, then you're gonna have ml square. These terms are not variable, so only this term is differentiable. So if you differentiate it theta dot again with respect to time, then here you're gonna get double dot, right? So now let's find del L by del theta. Let's find del L by del theta. If you differentiate it with respect to theta, so here the second part of this contain theta. So that's why let me write here m into z minus a omega square sine omega t. If you differentiate L cos omega t, if you derivative of cos omega t is minus sine omega t, sorry, not omega t, here theta, derivative of cos theta with respect to theta, that's going to be minus sine theta, right? And this minus and this minus, that's going to be plus, so we can make it plus, so we can write L sine theta simply, right? Hope you have understood this. Now let's plug in this value here in equation number 1. So from equation number 1, what you're gonna have, so this part is equal to now ml square theta double dot, ml square theta double dot minus this one is equal to this del L by del theta is m into g minus a omega square sine omega t L sine theta. That's what you're gonna have. Is equal to 0. Sorry, I forgot to put that. Is equal to 0. Now let's divide both sides by ml square. If you divide this one by ml square, divide okay, this by ml square. If you divide both sides by ml square, then cancel, l square as l square cancels. So what we're gonna have here, we're gonna have, so dividing both sides by ml square, here we're gonna have theta double dot minus g by l minus a by l omega square sine omega t and sine theta is equal to 0. That is what we're gonna have, right? That is what we're gonna have. So hope you have understood this, and this is the required equation. This is the required differential equation of this inverted pendulum, right? Thank you for watching. See you in the next video. Please do subscribe the channel, hit the thumbs up button, also share with your friends. Inspire me to create new contents for you, right? So see you in the next video. Thank you.